All right, so we've talked about speed, velocity, displacement, distance, vectors, scalars, how to find some of these things mathematically. Now we're going to look at what happens if we graph our position versus our time. So what we use position time graphs for is just to show data in a different way instead of just having numbers. We can look at it visually. Usually when we do a position time graph, right, we want to put time on the x and position on the y. Position, meters, times seconds. That's normally what we would do. So we take our data table and we plot our points, and we try to draw the best fit line that we can. So as you can see over here, we've taken our data and we've plotted it, and we drew a line to show that. Okay, and so this is our position time graph. Pretty simple to look at. The best fit line can give us other information about the motion, and we'll talk about what that means. So now, what we can do with the best fit line is we can extrapolate up if we got a nice straight line, so we can see what's going to continue to happen with the movement, right? We also can use this to find at any point how long it's going to take to get us at what point away from our origin. So we know if we want to be 1.25 meters away from our origin with this line, it would take 2.5 seconds. So we can continue to do things with this graph and gather information about the movement at any point during this path. Now, the slope, if you recall from algebra, is rise over run. We can use any 2 points along this line to find the slope, but here's the big one, is that the position time graph, the rise, okay, is position, and the run is the time. So rise over run, position over time, and you can see this is going to lead us to velocity before long. So the slope of a position time graph is our average velocity, which is really nice, because now we can find the slope and see velocity without having to do a bunch of calculations, unless you find that easier than using slope, which might be. But if we have graphing software that tells us slope, that information is provided. But if we pick 2 points, here and here, we ran over 3, we rose up 1.5, 1.5 divided by 3, right? There is our velocity, our average velocity during that time frame. Really nice and easy if we have a good graph. Now, straight line on a position time graph can have a positive, negative, or zero slope. So let's look at this. If our slope is positive, we're moving in we are having a constant velocity in the positive direction. If we look at these two here and compare this line to this line, more slope means a faster velocity. A flat line, zero slope, means zero velocity, which means we are at rest. And then, of course, you have a negative slope, which means a negative velocity. Now remember, negative velocity and positive velocity does not mean fast or slow when we compare them. It just means the direction. This is going in the positive direction. This is going in the negative direction. This one is going to the right. This one is going to the left. It's the slope that determines fast or slow. And with zero slope, that means we are at rest. So, the greater the slope, the greater the velocity. The slope of a tangent line, okay, equals instantaneous velocity. So if we pick any point along that line, we can find instantaneous.